Lesson 1-4 is on properties of numbers. Just so you know, I do not expect you to memorize these properties, but I do want you to become familiar with them because we'll be using them a lot in algebra. So a property is simply a statement that is true for any number. You can prove it. It's true, and it happens that way again and again and again, no matter what numbers you use. The commutative property shows that changing the order does not change the answer. So, for example, a plus b is the same as b plus a times b is the same as b times a. So, for example, 3 plus 4, 4 plus 3, doesn't matter how you say it, how you write it, your answer is going to be 7. Same thing with 5 times 2, 2 times 5, either way, your answer is 10. The associative property. This states that changing the grouping symbols does not change the outcome. Now, this is only if you look at the first example, everything is being added. And on the second example, everything is being multiplied. That's the formula. So 1 plus 2 is 3, and then add 3, you get 6. Well, on the other side of that, if you change the grouping symbols to do the last two first, 2 plus 3 is 5, 5 plus 1 is 6. Doesn't matter where you put the grouping symbols, your answer is going to be 6. Same with the multiplying. 2 times 4 is 8, then 8 times 6 is 48, or if you do it the other way, 4 times 6 is 24, then multiplied by 2, you get 48. Grouping symbols stay, doesn't matter what comes first, your answer is going to stay the same. The identity property says that if a number is added to 0 or multiplied by 1, the answer is the same as the original number. It holds its identity. It stays strong. So a plus 0, any number plus 0, is any number. And any number times 1 will be any number. So there's some examples there for you. So the 0 property of multiplication states that the product, the answer of any number and 0 is always going to be 0. So any number times 0, I don't care what it is, it's going to be 0. So yeah, 1,000,002 times 0 is 0. Last thing I want to talk about are counterexamples. And what that is it's an example that shows a statement is not true. You've got to prove that it's not true. So we're going to be looking at some of those tomorrow. All right, I will see you then.